Welcome. We're going to be doing shaders today. This is episode 1 of the OpenGL. I'm Blades and let's see if my typing's up to anything today. This will be fun. So let's start our shaders. It's OpenGL, isn't it? So source, new folder. Let's call it OpenGL. There we go. We now have an OpenGL folder. And in here, we'll start with shaders. So we need a couple of shaders, don't we? New file. And I'm going to call the first file ShaderFoundation. There we go. And the second file, oops, nope, the first file should be the header file. Oh dear, here we go. Ah, bless, you can see I haven't programmed for a couple of days, can't you? .h, and we need new file, shader, foundation. I'm using that capitals again, aren't I? Never mind, CPP. It's the way I prefer to do it, actually, I'll be honest with you. And my preferred way is always to capitalise the second word. I don't know why. It just pulls it out a little bit, I suppose. So, I'm going to... Oh, right, yeah. Better do this one, hadn't we? So it's space, and then it's hash include. And that's going to be ShaderFoundation.h. There we go. And give it a few spaces. Lovely. That's you done. And saved. Hash paraga once. There we go. Includes. Glue, definitely, because we are going to be doing OpenGL. Hash include. How do I get glue on this machine? It's GL, is it? Capitals? Yes, it is. And then it's glue.h. There we go. Nice of it to help out for once. I'm also going to do something that I don't normally do. I'm actually going to include IOStream, because printf is C, IOStream is C++, but IOStream is going to give us something that printf doesn't give. So I'm going to be using CERR function from it, the C error function, console error basically. IOStream. So we're going to be doing some error programming in this as well for everything else. This is a foundation one, isn't it? Yeah. So on the foundation, we're going to need to read in our GLSL stuff. So what am I doing here? I'm talking and thinking different things and then trying to type at the same time. That's great, isn't it? So that's fstream we'll need for that. That's our file system for reading and writing files from the disk. We're going to need file names, so those are going to be strings. So we'll have string as well, please. Anything else? Yes. .. We will need maths. And we have a maths.h. Well, I'll put one in. I'll just put that on screen. All it does is include the vector 3D and the matrix 4D. Saves me, if I add any more maths, it means it automatically gets included then. It's just a lazy way of doing things, put it that way. So I will use that, I think. So it's maths. And then it's that one there. Maths.h. It's got to be a .h, yeah. There we go. And we should be hash including it, because I'm an idiot. There we go. That's a lot better. Yeah. Quite a few includes. Yeah, so I've tried to say what they're all for, but I got a feeling we may need more maths in this. Not sure yet, but I know that we're going to need some maths because of the way shaders work. So let's see how a shader works, shall we? The internals of our shader. This program is going to be included within any other shader that we ever make. So all other shaders that we ever write will have this as its base, its foundation, which is why I called it ShaderFoundation. I was going to call it Shader Base, and then thought, well, foundation sounds better and actually means more correctly what it is, whereas a base could be anything, really, I suppose. So let's have a few namespaces. We'll have our standard namespace of Amber. Good place to start. And a namespace, if I get my fingers to work today, of OpenGL. So everything's going to go under OpenGL. Lovely. That's good stuff. And today's class is ShaderFoundation. Remember the capitals. Foundation. Yeah, dear, my brain's off somewhere else today. That's okay. We don't mind. So we'll have that. Come down, give it a semicolon because it needs it. It's C++. And there we have our class. So, what kind of variables are we going to need? Not many. This is a foundation class. This is not really going to be storing much. The shaders may store more, but as a foundation, we're not going to be doing too much. I'm going to put in static const unsigned. This is a great one, this one. Unsigned int. You've never seen anything like that before. And I'm going to call it num shaders, all in capitals, please, because it's a const. Shaders. And that's just going to tell me that there are 2 shaders. That's all that's going to do. Reason for that is I will possibly need to reference how many shaders we're writing. So this shader foundation will be the foundation for 2 shaders. If we write a 3rd shader, then we'll change that number to 3. Simple as. No problem. I'm going to use GLU ints now because we are in OpenGL. We should use the OpenGL unsigned ints, although I didn't with the num shaders. But this is the GL stuff, so we are going to have, let's see, shaders. We're going to store them here. And that's going to be num shaders, please. I haven't done that right. Sorry, my bad. That's not right. That should be a square bracket. Silly me. Wrong bracket type. That's an array. That's just an array of shaders. What we're going to do is store each shader in there so we can use it. There we go. OpenGL will pass us a handle, a reference to where the shader is on the graphics card, and OpenGL will store it in mshaders, and every time we want to reference the shader on the graphics card, then that's what we're going to use. Now please remember the shaders are going to be on the graphics card. They are not going to be in our standard memory. They are part of the graphics system, the OpenGL system. And so we'll need a program as well, won't we? We better take one of those. Int, and that's just going to be mprogram for now. Might need to change that, don't know. So each of the shaders is an actual program, as you saw from the GLSL part in the previous stage where we wrote the GLSL programs. That's what they are. Now, we've got everything, I think. I can't think of anything else off the top of my head, so let's go public and start setting it all up. So the first thing we're going to have, obviously, is going to be ShaderFoundation. There we go, ShaderFoundation. Are we going to do anything with it? Yeah, we're going to do what we normally do, which is a standard std string. Remember, that's in the std, the standard library, because we've got the include up here. That's that part. And we're going to call this, we're just going to take the address of whatever file name is passed in. And am I going to call this file name or file path? File name. Okay. I'll call it file name for now because I think that's all we're going to need. We know where everything is, where everything's stored because we stored it. Let's see what else we're going to need. Oh, something new. This is going to be a special function that we are going to include in a very special way with our shaders. So we are going to, some of the parts in this are going to be virtual. In other words, we don't specify it, the shader will specify it. So I'm going to give a virtual destructor function to the ShaderFoundation. That means that another function can destroy through here, or is allowed then to destruct whatever we've put in here. So the controlling function can then destroy these if needed. Not sure it's needed, but I will put it in for now. For each shader we are going to need two functions. We are going to need to be able to start the shader, there we go, let's get that right. Start the shader, and, well, I think you can guess the other one. Stop the shader after we're done. So we will start it using the start function. The shader will run. We will deliver all our data, and then we'll stop the shader. And we can obviously start individual shaders and stop them, and then start the next shader and stop it. But you can only use one shader at once, please. Please, please, please understand we can only use one at once. This is actually a GLUint. GLUint. And this is going to be get program ID. We're going to have an ID for each program, so we need that so we can get hold of it. And that is just going to return. It's a simple getter. It's nothing more, and that's just going to be mProgram. That's going to be our program ID. I could call it program ID, couldn't I? There you go. Makes more sense now, doesn't it? It reads right. If something doesn't read right, change it. Simple as. Aha, there we go. I need a semicolon somewhere here. Where does it go? It goes there. There we go. It goes at the end of the line. That's okay. What else are we going to need? We've got the program. We're going to need a load of technical stuff now, aren't we? Yeah. Yes, we are. We are going to need floats, vectors, and matrices. I'm going to add booleans as well. Heck, why not? When we use a shader, if you remember, going back, I'll put it on screen, why not? It's in the API, under GLSL. And I will take basic shader. I'll take the first shader, which is the vertex shader. We have these location zeros, vec3, vec2. Now, I've got vec2 as well. Is that going to be okay? Yeah, because we can pass in as a vec3, or can we not? We may have to change that to a vec3. Don't know at this stage, but what I'm going to do is I'm going to modify this code as we go along to include everything and make sure that we can do everything. Text coords I haven't thought about, so that's my apology. But these we need to pass. We need to tell OpenGL what data refers to each of these. It's got this position. It knows it's in location 0. Well, we have to tell it in the shader. What? Where's that going to come from? So what we're going to do is link it all together using a void. Yeah, void. Yeah. Microphone's a bit far away. Excuse me on that one. So I'm going to call it load fault. The first one I'll do is a float. So, yeah, and all that's going to do is take an int location. So I don't know which location it's going to be. So you can designate the location. The user can designate the location. They can write their own shaders, can't they? Nothing's stopping the user writing their own shader. So they can specify the location there. Float value. We just need the address of the value. We don't need the actual value itself. Okay, so that will give that. Let's continue that on and do a vector. Just call it load vector. Why not? And that's going to be an int location. They're all going to be int locations. You know where that's coming from. That's coming from this location business here. So that's okay. You know where, and you know that's, if you watch the video, you know how I got those locations and where they came from and how they refer back to the other parts of the API. So that all joins up nicely. It's a bit, yeah, it's a bit of a jigsaw puzzle, and that's why I say that it's never fixed. We haven't used maths, have we? Maths is inside Amber, so I don't need to. Excellent. We didn't give it a maths namespace. This is why. This is why I didn't. So I can just put in vec3 now, can't I? Yeah. Excellent. Isn't that nice? I think it works out quite well. And we'll take the address of the vector there, please. There we go. Void. What else do we want? We'll do a boolean. We'll add booleans in. We don't need to, but I'm going to add it anyway, just in case somebody wants to use a boolean. It's actually, I might want to. Later on down the line, when I put in colours, coloured objects rather than textured objects, I may just alter the, let's see, the static shader to use a boolean, true or false, on textures or colours, so that it can switch its operation within the GLSL code between using a texture or just using the colour of the object, which would be really neat, because then I would have one shader doing both instead of having to write another shader. I'm thinking about doing it, but hey ho, let's see if we do. And that's just going to be an AND value, true or false, and value. There we go. That's that one done. Oh, excuse me breathing. Let me just get some coffee as I type with one hand. That's mighty fine coffee. The last one is Matrix. So that's in the location. and comma, and that's just going to be map4, which we've got in maths. We made it, we created it, we wrote that in stage 2 C++. If you want to refer back to it, and we'll just call it matrix because we can. Why not? And it's an AND value, isn't it? Don't know if that would work, so I'm not going to do it. We'll leave it as that for now. Could well be. I'll look into that. Part. Protected. This is another one you haven't seen before. Protected. Now, because this is a virtual function, not a true virtual function, in other words, all of these aren't empty. A true virtual function would have virtual at the beginning of each one of these, and it'd just be empty. You wouldn't have anything in there. This isn't a true virtual function, it's just a virtual one. You've probably never done one before, but here we go. We're going to put some virtual bits in here. So protected, which means that the function that it belongs to can access whatever functions we place in here, but no other function can. Any function can ask for the public parts. The protected parts can be used by the controlling function, because this is just a foundation, and the private bits can only be handled by the ShaderFoundation part itself. So here I'm going to put in a virtual function, just for handiness. It's a void, and it's going to be called bind attributes. Attributes is a list of things. Attributes, and of course it's got to be empty because it's virtual, or empty-ish anyway. Or I'm not even sure I need to do it like that. Can I not just? No, for completeness, I will put the definition into the .cpp. You don't have to, you can just put open close brackets, I suppose. I don't know, it depends on your programming style, but for completeness I'll do that. And the bit that we want to do with the bind attributes is void bind attribute, each one in turn. It's a bit confusing, this. It's a bit hard to explain as well, without the S on the end, please. That's a separate function, and this is going to be a gluint attribute, and it's also going to be a const jar star, and that is going to be variable name, isn't it? I don't like putting the star there. Sorry. People do. You'll see it in anything that you read, const char star. They always put the star after the char. I don't like to, because it doesn't belong to the char. It belongs to the name, the variable name, which in this case is variable name. Yeah. What we're going to be doing here with these bind attributes and binding each attribute in turn is taking our shader and finding out what they're called. We are going to be binding each of these names to a name that we have either in our API or within our C++. I think it goes into the API, or into, yeah, I think it is the API. We'll find out as I get to it and I do it properly and everything, so don't worry, we'll be able to explain it better then. It's a hard one to explain. So that's our protected stuff. That's what our main shaders or our main shader programs will be able to access, special functions. What else will we need? We'll need private stuff, won't we? Yeah. There's always some private stuff on these. Oh, this is possibly the largest one you've seen me do. It's got a lot of complexity in here because not only is a shader its own program, we have to construct it and compile it. Yeah. Great. So glueInt. We will have create shader. There we go. I'll have that. And I will want a const std : string, and that will be and text, something you won't have seen before. I haven't used one of these either. It's a GLEnum. You've seen me use plenty of them, but you probably don't know that the GLEnums, those are those capitalized things that I've been using, like GL texture, you know, like GL texture 2D and stuff like that. All of that rubbish that we were using before, that's GLEnum. We're going to be passing one through for once, and it's going to be called shader type, because there are two different types of shaders. There's a vertex shader and there's a fragment shader, and we have to compile them separately. So we have to know which shader type we are compiling, and on the create shader side. That's a beautiful function, that one. You're going to really love it, because it shows how C++ is compiled at the same time. And that makes it more interesting for me, because I'll be able to show you how things are compiled and how we program an automatic compiler for shaders. That's going to be nice. Next thing I'm going to need is some way, it's going to be a string, isn't it? Some way of loading those shaders. And of course the name is a string. And load shader, what do we need for that? We'll need the file name, won't we? Yeah, so it's const standard string, and it's just going to be and file name. So all of this is subject to change. Please, please, please bear in mind, this is just me reading me notes on what we need to do, and hopefully getting as many of these functions up and running as possible. So I would want to refer to the string, yeah. Okay, I think that one's right. Load shader, yeah. Yeah, I think we're right with that. Okay. And we're going to have an error system. Check shader error. The reason we're doing this is because when compiling, it's out of our hands. It's not going to be in our hands if there's an error. So if an error is generated, it's going to be very, very hard for us to debug our shaders if we have no idea what those errors are. It'll just say, oh, we couldn't do the shader, and that's it. No, that's not going to be good enough. We need to know what's wrong with our shaders. Have we programmed them correctly? That's an interesting thought. I think we have. I'm sure we have, but I'm going to check. Just as when we compile this program, this system will check and chuck out errors. Well, when we compile a shader, that system will chuck out errors as well. So let's do it. So we'll have a flag. Let's have, what else can we have? Is program, yeah. You'll see how all of this is used. Oh dear, my throat's just gone, so I'll just cough a little bit. And let's find some coffee. What else are we going to need? Let's think about it. Coffee's on its way to going cold now, so it's a const. We are going to need a string for the error. So string, and we'll call that the, we'll have an and, we'll just have the address of the error message. Standard string is correct. Go away. Thank you. Right, I think for now that's enough. I've thrown enough at you. I think from there we can start building what I can only call a full foundation, all the foundation programming for a shader. We should be able to fit into here. If we can't, we may have to add a few more things here. I've just put load matrix, but it isn't, is it? It's map 4, so that is actually load matrix 4D. I'm just wondering, should I put a 4 on the end? We should really, because what happens if we want a 3D one? Or a 2D one? Never thought about that before. It's like this vector, this is a vector 3. What about vector 2s? Not sure. Not sure. Not sure. May have to change it. Anyway, so there's a lot of uncertainties there for me. Because I'm thinking ahead so far, it becomes uncertain on what I'm going to need and what I'm not going to need. Unfortunate, really. So I'm going to save that. I'm going to keep that. Don't need that. Don't need that. Do need this. So this is going to be namespace. Namespace, and it's going to be amber. And we're going to have a namespace of OpenGL. And then from here, I am going to copy public all the way through to there. All of those functions we have to write. Yay! We get to get out of the way. We have to do some programming for once. Yay! It's not just a straightforward storage. There's a lot of information there. So, how are we going to do this? I think we're going to, first of all, Shift-Alt down here. Bring you lot back. This line I'm going to replace with that. Bring these two back, can't I? No, just one up and do. There we go. This line I will also replace with that, just as a break in the code. And these ones. Alt, drag, delete. Nice. Now what we do is we take ShaderFoundation, we copy it, and we place it in front of everything. Control V, colon, colon, Control V, colon, colon, make them all members of ShaderFoundation. That's what that means. Get program as well. Colon, colon. Yep, nothing special going on here. I'm just doing the edits required to make them into functions that are, whoops, into functions that are members of Shader program, ShaderFoundation, sorry. Oh, what have I done wrong here? Okay, Control V. No. Thank you, computer, you've altered. Thank you. Colon. V, colon. Yeah, it's a bit of a mess about and everything. Quite a lot of the editors that you can use do this for you, which is very nice. I do like that kind of functionality. Unfortunately, this is just a text editor. So, well, it's a glorified programmable text editor, maybe, but it is a text editor and doesn't have all these special things. So at the end of that, it's colon, brackets. At the end of that, take off the colon and put in the brackets. That's virtual, yeah, that's fine. Take off that and put in the brackets. Yeah, I know. Why am I not allowed to have that const? I suppose I'll find out sometime. Didn't need that line at all. Tink. That's already been done. So it's float, yeah. Next function. Lot of functions, I know. Not usually this bad, but this will save us writing all of these functions for every single shader every single time. That's the beauty of this. Once we've done it once, we don't need to do it again. And it makes, when we write the shaders, oh my god, does it make it simple. Because everything's been done for us already. Well, most things. There we go, that's that. That's looking good. And the last one. No, I just want to put things in. Oh god, it's going to do this silly thing, is it? I hate this text editor, but hey ho. It's the only thing I can work with. Where I know I'm not going to get a lawsuit if I send anything out to you guys. Especially if you pay me on Patreon and then I send out the code, I would be in a lot of trouble using something like Qt or Visual Studio. Now I've got a problem here. What's the problem? Can I remember how to do these? The answer is yeah, of course you can. There's nothing wrong with a constant. What's wrong with you? Oh yes, there is. Got to make ShaderFoundation a member of itself. Come on. Come on, Blades, wake up. Thank you. And the virtual function doesn't have to have the word virtual in front of it for a second time. It only needs it in the declaration, not in the definition. So there we go. Put space there and space there. Yeah, I think that's okay. This video is now long enough. I've thrown a load of functions, blank functions at you. I mean, if you can know how to write any of these functions, feel free. Just go ahead. Take virtual off. You don't need it there. Go ahead and write them. I don't mind. But in the next episode, I am going to try and get through as many of these as I can for you and see if we can make any sense out of any of it. What we'll do is we will probably start at the bottom and work our way back up, because it's going to be obvious that the very first, this one here, is going to rely quite a lot on things like create shader and stuff like that. So I don't know if I've got everything right here. We shall find out. We shall find out. It's going to be an interesting journey. next episode. It is for me, and I hope you have enjoyed this little talk through of shaders, although I'm trying not to go into depth about any of it. The programming side of it is not too difficult, to be quite honest with you, because we are going to be following the path of how something is compiled. So I think what we're going to do is start here, create shader, load shader, and check shader. I think because this is the heart of it. This is what we're going to be really working with, which is all the private bits. So yeah, I think that's where we'll start. We'll start on these bottom ones, and then go through the rest as needed. Excellent plan. We have a plan going forwards, and I'll see you in the next episode for part 2 of ShaderFoundation and coding up. It's going to be fun, and in the between times, you people, please take care and have some fun. Alright, cheers.